Until now, the basic statistics have been sufficient. Now let's examine the application layer. Let's open the file with the captured telnet session. This is a protocol that's very easy to interpret. It's easy for us, humans, to read what the client sent to the server and how the server responded. We can see that two computers exchanged communication. The first three packets visible were responsible for a proper establishment of the TCP session by a three-way handshake. Below, you can see that the telnet was turned on. However, it's difficult to tell how the communication proceeded. We won't analyze a packet after packet. Clicking on any of the telnet packets with the right mouse button opens the context menu with the Follow Stream option. Follow TCP stream, follow UDP stream, follow SSL stream. We will choose Follow TCP stream. It allows us to see the whole of communication, unpacked from the headers of the lower layer packets. We now see the raw data. We can see the data that the client contributed or how the server responded. In our case, we see the original conversation. The user has logged in with telnet. In the fourth row from the top, everything is doubled. This means that the program captured echo. After the user pressed a keyboard button, a character appeared on the screen. The server sent back the echo of the buttons the user pressed. After typing the password and logging in, please note that there's no echoes of the password. Some information on the remote server was displayed and the client logged out. Follow TCP stream allows you to trace this kind of communication. If we'd used this feature earlier with the HTTP server, it would have pointed to a communication between the browser and the website. Now let's look at something more related to security. We open another capture file. It presents a situation you would not ever want to have in your network. Just looking at the main window, you can more or less get what's going on. First, you can see the TCP session establishment. Then there's an attempt to log in to the FTP server as an administrator with a random password. By clicking on the selected packet with the right mouse button, we can choose Follow a TCP stream. We see that someone tried to guess the administrator's password. We would like Wireshark to highlight issues like this one at once. To do this, you should first prepare your own profile. It can be called, for example, sec, like in security. From now on, we'll perform every action in the new profile. We'll now create coloring rules or filtering rules for specific packets. The point of that is to enable you to choose a pre-configured profile, management, security, etc., whenever you turn Wireshark on. We're now checking on the FTP protocol. Let's see how the user tried to guess the password. Remember that any piece of data can be used as a filter. If we applied the filter FTP request command == user, we would be shown only logging requests to the FTP server. If we only wanted to see the failed attempts, we should select the password, not accepted packet. Click on it with the right mouse button and choose the options Apply as Filter or Selected. Let's now create a coloring rule. We would like to color a situation in which the password was not accepted. Right mouse key, Colorize with Filter, New Coloring Rule. We will call the new rule Bad FTP Pass. Now, choose the background color. I suggest you choose a really annoying one. There are already a few coloring rules in Wireshark. Because the rules are applied in sequence, it's more important that our rule is first. From now on, we'll be able to spot the packets we would never like to see in the file. In this way, we've created our own intrusion detection system. Let's look at the attempt to guess the password to another service. We'll open another capture file. The protocol used to communicate with the Microsoft SQL servers is the TDS, Tabular Data Stream Protocol. As you can see, Wireshark correctly interprets the data of this protocol. Not only did it show that such a protocol was used, but it also properly interpreted its header. Wireshark correctly interprets a large set of protocols, virtually all of them. If it doesn't manage to do so, it means that someone uses a really strange protocol or an unusual port, and that you'll have to manually decode the data. Usually, all data are properly interpreted by Wireshark. We'll filter data according to the TDS protocol to see if there are any troubling messages. We see that someone has tried to use the server name SA to connect to the computer named SYD S21ESXi, with a server with a visible IP address and listening on port 1433. Filtering the data sent by the server according to IP addresses would be faster, but it would give the same result. We have the error message reported by the SQL server, which is understandable even for people unfamiliar with databases. It contains information that SQL Server reports an error when someone tries to log in with the wrong password. The error message number is 18456. We can use the error number as a filter or as a coloring rule. We can check how many times someone tried to log into this server. We would like to know how frequently these attempts were. In the table above, we can see the total time since beginning of capture. You can change this to the time elapsed since the last capture. Now it's easier for us to analyze the data. We can see that someone sitting at a computer with the IP address displayed, source, tried to log into the SQL server more often than every 39 milliseconds. Either this is a person who types really fast or uses a brute force program to acquire unauthorized access to the server.